take a look. So if we go to our notebook, here's our agenda for the day. So the first thing that we're looking at is, well, what the last lab was about, the virtual lab, was looking at why we see what we see when an eclipse occurs. So when an eclipse occurs, the most striking part of it is the light that's emanating out of the edges of it. So it was a mystery as to why, if the moon was blocking the sun, you could still see light coming around the edges of the moon. So shouldn't the sun have completely blocked all the light? But that's not the case. So if we look back just at the picture of our last warm-up there, we can see all of the light coming out from the sides of the moon there. So why is that? So we started looking at one of the properties of light in the last virtual lab, and that's that light can actually bend. So when light hits different substances, the speed of light actually changes, and that causes a bending of the light. So if any of you have ever put a pencil or a straw into a glass of water and looked at it, the straw looks like it breaks. So if you look at the side of the glass, the straw or the pencil that's sitting in the water looks like it has been broken. That's because of the speed of light changing within the water. So that makes it look like the pencil is actually broken. And that's kind of what we have going on here. So today we're going to do an actual physical lab over the same concept. So we are going to actually measure the speed of light within a plastic type substance. And we can do that by determining the angle that the light bends at. So that's what today's lab is going to be about. So yesterday's lab was just a virtual lab looking at the idea of bending of light. So the first thing that we do here in the warm-up is Einstein is the guy who first came up with the theory of why we see what we see when we look at an eclipse. So it's slightly different than the speed of light changing when it goes through a certain material, but kind of the concept to me was a bit of the same, just the fact that light can bend. But that's not really what's going on in this picture here. So it's not that here the light is traveling through a different substance and is bending around the moon. It's actually the gravitational pull of the moon that's bending the light. So Einstein was the first to propose that, and it was actually an eclipse that allowed Einstein's theory to be proven. So before the careful study of the different locations of light sources during an eclipse, there was no way to actually prove Einstein's idea. It was just his theory as to what was going on. So this is a bit of background on that. So it's a little 5-minute video on that. Then here's our lab. So you're going to find the lab in the actual assignments tab. So we'll go to that in a second. And then the reflection is just after you write a 1 paragraph, 5 to 7 sentences about what you've learned about light over the past couple days. So if we go into our team site here. So if you click on the assignments, here's the assignment 315. So experimental determination of the index of refraction of acrylic. So there's your assignment, the actual lab sheet there. So when you open this up, what you want to do is you want to go ahead and come over here and open it in a browser. Otherwise, the formatting is all screwed up. So we'll just open it up in the browser here. So you're going to write on it right here. And again, it just saves automatically. And then you just go back to the Teams site there and submit it. So the purpose of this lab is to measure the index of refraction of an acrylic block. So the question that the experiment is meant to answer is, do you think the index of refraction of acrylic will be more than water or less? So this is not really that important to me at this point, whether you know what this stuff means. I'm just kind of using a lab that normally I would use much later in the year. But what I want to look at, the main purpose is I want you to see the bending of light. So this is a good lab to actually get an idea, get an actual visual idea of how light bends. And the second thing is we're going to, again, practice our spreadsheets. So down here, this is where you're going to collect your data. So if you click on this, Download this. No, I'm not editing it. So it'll be different on yours. So when this is where you're going to enter your data here. So I've put a spreadsheet in here. And it's also where you're going to do your data analysis. They'll do that. Oh, don't it? They'll do that your data analysis there too. So that's kind of the second main purpose of this. I don't know why these pictures formatting all screwed up. And here are the equations you'll use. So I've given you the equations for these. So you're just responsible for kind of plugging it in. I've actually given it to you in there as well. So there's two different equations right there that will be used. All right, so here are the procedures. So this is a bit confusing. So I'm going to draw a little picture for us. My white. So I'm going to draw a little picture of what these mean. Whenever this comes up. So there's only four pieces of equipment that we need: cardboard, an acrylic block, 3 pins, and a protractor. So what you're going to do is, well, I guess we need a piece of paper too. That down there. I'll put white paper on there. So here's what we're going to do with this. So you're going to put your piece of paper, your piece of white paper onto the cardboard sheet. And then you're going to draw a horizontal and a vertical line. So basically you're going to cut your paper in half both ways. And then you're going to put a pin. One of the 3 pins is going to go straight into the middle of the piece of paper, which is what these pictures should show. So let's bring this up here. Slow. So let's say this is your cardboard box. Or your piece of cardboard. So you're just going to take your paper, and the piece of paper is going to go onto the actual sheet of cardboard here. And then what you're going to do is you're going to just you're going to separate the piece of paper in half lengthways and widthways. So it doesn't have to be exact here. And then what you're going to do is you're going to take your pin, and you're going to put your pin right in the center spot there. Okay, so that's the first thing. Then you're going to take your acrylic block, and you're going to line it up against the pin. So you're going to take your acrylic block, and you're just going to put it against the pin here. Okay, so we just lay the acrylic block against the pin. And then you're going to place a second pin randomly above the block. So it doesn't matter where you put the pin. So you're just going to take a second pin and you're going to put it, doesn't matter, somewhere up here. So we want this in quadrant 2 of the block. Okay. Then what you're going to do is you're going to get down to eye level, and you're going to look in this direction. So you're going to look in this direction through the side of the block. So I'm going to come over here and just draw a picture of the side of the block. So when you first look at the side of the block, this is what you'll see. You'll see a pin here, and you'll see another pin over here. So you'll see these pins here. What you're going to do is you're going to move. So you're going to move your eye level left or right until both of these pins come together. So what you want to see is these pins disappear you want the second pin to disappear behind the first. So again, you can either turn the whole thing back and forth, like you can just shift the entire piece of cardboard back and forth, or you can move with your eye. But what you want to see when you look through here is there's pin number 1, and you want pin number 2 to be directly behind it. So you want the second pin to have completely disappeared behind that. Okay, then what you're going to do with the third pin is look to the side of the block and then place the third pin so it covers all of these other 2 pins. So you're going to look through the side of the block, and then you're going to take the third pin and you're going to place it in front here of the block. So you want to place the third pin somewhere where it lines up. You want it to place it perfectly, so the third pin is now here as well. So you want all 3 pins to be in a line like this. Okay, so the third pin is going to be somewhere like this. When you actually stand up and look, this is what you're going to see. You're going to see that these pins are not lined up in a straight line like they should. Looking at it through the side, it looks like the pins are it would all be a straight line. So it looks like it would be a straight line. But when you look at it from the side, what you're going to see is when you connect these dots, you're going to see that it's not a straight line. Okay, so this is now where you're going to take your data. So what you're going to do is now you're going to remove the block. So you're going to take the block out of there. So you'll take the block off. And then you'll get your protractor. And you're going to measure these 2 angles. So we want to measure the angle right here. So this is going to be angle number 1. And then you want to measure this angle. This be angle number 2. So this is called your angle of incidence. So this is where the light is coming from to your eyes. So the light is coming in this direction, then it hits the block and it exits the block in this direction. So this is your refracted angle. And this is your angle of incidence. So then you'll record that. So you'll come back over to our lab sheet. And you'll go down here, and this is what you'll record. So for the first trial, the angle of incidence goes in there, then the refracted angle goes there. So again, based on what you saw, what your eye saw here, these should be exactly the same, but you'll see they're not the same. So this is where light bends. So this is the bending of light as it moves through this block. And again, the light is bending because the block is actually slowing the speed of light down. So it's causing the light to, and to your eye at least, bend. And again, this is why when you put a pencil or a straw into a glass of water, it looks like it's been broken, because light is moving at a slower speed in that glass of water. Okay, so what you're then going to do is you're going to repeat this 4 more times. So we're going to take 4. We're going to do the same thing 4 times. So each time, you're going to just put the second pin up here in a different random spot. So if we take this, so in the second trial, you'll just start all over again. So instead of putting the pin there, leave that in there. So you'll just take your pin, and it's, let's say that was pin number 1. Maybe you'll put it over here this time. So the second time you'll put the pin over here. Maybe the third time you decide I'll put the pin over here. And the 4th time, who knows, 4, 5. You just put the pin in 5 different random spots, and then you do the same thing. So you look through the side and you move the block until those first two pins line up, and then you put the third pin right in front of it so that all three pins look like disappear behind each other. So it looks like there's only one pin there. And then we just measure the different angles that come out of it. And those angles then go into here. So you see here, I gave you the equation. So here, what you can do is you can just copy this equation into here for you. So all you need to do is fill in the incident angle and the refracted angle. So this is where you would just, when you write the equation, you would do equals, and then you would type in the word sine, and then you do parentheses, and you would just click on here. So there's your incidence angle. So you click on that cell, close it off, divided by, and then you type out sine again. And then refracted angle, you'd click on there, close the parentheses off, hit equal, and that would give you your value there. So then at the end, what you're going to do is you're going to get an average index of refraction. And this is how you do the average here. So it's really easy, and that Excel actually already has this laid out. So all you have to do is go up here to the auto sum function, hit the word average, and it will average this whole number out for you. So all five, so instead of you having to do the average calculation on your own, you just click on average, and the computer program does average for you. And then the last thing you do is we just want to calculate how fast the light is moving in the acrylic, and that's the equation for that. So you just take the speed of light in air. So in regular air, light travels at 3 × 10⁸ meters per second. So we just take this number divided by whatever this average is here, and that will be the velocity of light within the acrylic. So again, when we talk about refraction, what that means is light is bending, something is bending. So something is being refracted. What that means is it's being bent. Okay, so these are really the two big things I want you to get out of the lab. I don't care about this, whether you know about this equation and that kind of stuff. I just want you to know, one, that light bends when it hits different substances, and that's because it's moving at a different velocity. And two, we're practicing our spreadsheet work. So that's the main thing here. So this again is relating back to the eclipse, and that we're talking about the bending of light. So the reason that we see what we see when we look at an eclipse is because light is actually bent, and it's a really important property of light. So the bending of light allows scientists to decipher a lot of information about stuff that they otherwise would never be able to know anything about. So when we talk about stars and galaxies and things like that, the light that's reaching us is, again, all of the information. It carries all the information that we know about those objects. So that's the point here, is we're just looking at some new information, looking at some properties of light that allow us to know these things.